One area we didn't touch quite as much today is the security. And to see how you can ensure that security best practices are understood, architected for, and integrated into your application from the first day to years after, we have with us today Jerry Hargrove. He's a cloud evangelist at Lucid Software, a solution architect, and brings with him 20 years of experience working as a software architect, developer, and manager. As a fun fact, Jerry likes to climb in his spare time, go backcountry skiing, and he's also an avid hiker. So until Jerry comes to the stage, don't forget to rate our speakers for today.
All right.
Good luck.
Thanks a lot, everybody. So my name is Jerry. I'm now a cloud evangelist at Lucid Software. My background is as a software developer. I've been writing code for the last 20 or 25 years. Most recently, I've worked at AWS as a software developer there, and most recently at Rackspace as a software developer and solutions architect. So what I'm going to talk about today is some simple techniques that you can use on AWS or any public cloud provider to start integrating some DevSecOps principles and practices into your application. The title here is a little misleading. I'm actually not going to take 60 minutes. I'm going to take 40 minutes or less today. We're running a little bit behind, so we'll go ahead and get started. Whoops, I'm a little ahead. So what I'm going to talk about today are just some basic practices around DevSecOps. If you're familiar with DevSecOps, you probably understand that we're trying to move security to the left in the DevOps pipeline. So bring security in a little bit earlier. There's way too much topic there to cover in 30 minutes, so I'm going to focus on a couple specific problem areas on AWS and how you can solve some of those. My background is in AWS, and that's where my expertise is, but I've also worked with Azure, and I've worked with Google Cloud Platform, GCP. So I'll also be providing examples there as well. So let's jump right into this. I'm having a distance issue. How many of you are familiar with a company called CodeSpaces? Nobody, not familiar with it? Good. It was a company that was based on AWS. They ran a service that allowed you to host your application, host your projects, source control, et cetera, on AWS. This was several years ago. One day, CodeSpaces users got this email or this notification letting them know that CodeSpaces was down, that someone had compromised their system, the CodeSpaces system, got access to their AWS console and AWS resources, and started deleting AWS resources. That included AMIs, that included EBS volumes, that included backups. The next notice that customers received was, this is going to go ahead probably 5 slides. Maybe if you just move it closer to me, that's probably it. It's just a distance thing. There we go. They were down, they were closed. Ultimately, the system was compromised, their customer data was lost, and they had to close their doors. This is an example of the type of issue that you can run into on AWS. I forgot to ask, how many of you are actually using AWS either personally or as part of your job at your company? So a good, maybe a third. How many of you are using just public cloud in general, whether it be Azure or GCP or AWS? So we're at about a half then. Some other news, if you watch AWS news or just tech news in general, you may have seen some of these types of stories in the last year. S3 buckets being left exposed or being left public. And company assets, company secrets, customer information being exposed. These are just a couple of the news stories just over the last 12 months. It's something that happens all of the time, and this is one of the things that I want to talk a little bit about today, and some of the best practices that I'm going to talk about, how to solve that. So before I get into that, I want to kind of pare down the problem again just a little bit more, because there are things that you can do on AWS and on GCP and on Azure to help solve some of these problems, at least before they actually happen. And that is using tools like identity and access management to control access to some of these systems, to make sure that users have only the permissions that they need to accomplish their job, to establish the principle of least privileges. So those are types of things that we can do proactively to prevent account credentials from being lost, or account credentials from being used for purposes other than what they were designed for, and to also restrict access to systems. What I really want to talk about today is more reactive security. So a lot of these problems that we've seen in the news aren't that systems have been hacked, but simply that social engineering has been done to gain access to credentials to accounts. So they're using credentials, so they're using accounts that have the ability to perform these actions. So from a system perspective, you're looking and watching what's going on, there's really nothing problematic. So I'm going to focus on reactive security and some of the principles that we can use on AWS to deal with that. Design patterns. As software developers, we're probably all familiar with design patterns. If you've been in the industry long enough, you probably recognize this book that's on the screen, the Gang of Four Design Patterns book. I think this is probably out in the 90s, late 90s. It's been around for a long time. Design patterns are a great tool that we use in software development because they allow us to talk a similar language. So I can talk to you and you're writing code in Python, or you're writing code in Ruby or Go about a visitor pattern or some other type of pattern, and we can talk the same language regardless of the actual language we're using to implement it in. It also allows us to reuse design patterns from one project to another. So today I want to talk about event-driven software and how this design pattern can help us solve some of the DevSecOps problems that we're seeing. So really at a real high level, event-driven software is composed of these three components. And the names change depending on what text you look at or what description you're looking, but typically it's composed of these three components: a producer, a channel, or a consumer. A producer might be something that's generating events or initiating events or sending out messages. The channel, then you might also know it as a broker or a message broker or a message pipeline or manager. It takes those messages and delivers them to consumers. Consumers might be event syncs, they might be event notification mechanisms. The channel manages all of that. And so in effect, we decouple producers from consumers. And in general, that's a good idea in software development, and in particular in distributed systems. We want to decouple producers from consumers so that they can scale independent of one another, so that they can have independent failure mechanisms. We also allow, this decoupling allows the producer and the consumer, it allows us to subscribe multiple consumers to particular types of messages. So in general, it's a great practice. Many of us have probably been using it in projects that we've been working on for a long time. So the question is, how do we apply this to security? Well, in the context of, excuse me, of event-driven security, let's take a look at how you can actually do that on AWS. So looking at AWS, so if you're familiar with AWS, they have a slew of services and features that are available for us to use in the cloud. It's grown from a handful, maybe 6 or 7, 10 years ago. It's been, I think, since they first started, to hundreds now. And in terms of event producers, services that can produce events, AWS has a very large selection. And this list was based on about 6 months ago, and so I'm sure it's grown by now. So if you're familiar with AWS services, different services can generate events in their system, like AWS code build. So if you're building an application or excuse me, using code build, it can actually generate events based on different states that it goes through. Amazon EC2 can be used to generate events to, when instances start or when they stop or when they're terminated. You can also use any number of these ECS for container type applications. Can I grab a bottle of water here? Yeah. Or I am going to fall over. Thank you very much. So you have a wide variety of services that you can use on AWS to generate these events. And the one that I really want to focus on today is AWS CloudTrail, because it's the service that allows us to deal with some of the security problems that I was mentioning. AWS CloudTrail, for those of you who aren't familiar with it, gives you the ability to record interactions with your AWS resources. So for example, anytime someone logs into the AWS UI and starts an EC2 instance or creates an SQSQ or interacts with AWS in any way, all of those manifest themselves as API calls to the various services. So launch an EC2 instance, that ends up being a run instance API call. So with CloudTrail, you can actually capture all of those events and then deliver all of those events to an S3 bucket. If we look at how this actually works, here's a demonstration of it. A user perhaps logs into the UI, or they use one of the AWS SDKs to interact with an API. That API is captured by CloudTrail. CloudTrail aggregates that information and then places these log files in S3, in an S3 bucket for you to look at later. It's important to note that this is not real time. This is an asynchronous process. So it allows us to go in and do potentially forensic analysis on activity on your account at a later point in time. So a CloudTrail event contains information like you see on the screen here. You have a region that it occurs in, who initiated the event, so the IP address, so if somebody's logged in or an application is using one of the SDKs for AWS, you can see where that was initiated from. And in this case, again, it was an EC2 start instance call. So that's the type of event you get. Now, let's look at the channels on AWS. Now, really, there is only one. It's AWS CloudWatch Events. So this is the message broker that we're looking for to handle our AWS, our security events. It allows us to take those events from CloudTrail, and instead of having CloudTrail aggregate them and put them in an S3 bucket, it deals with them one-on-one. So you can get near real-time, not synchronous, still asynchronous processing, but have the ability to process them much quicker and route them to different consumers. And so a typical CloudWatch event might look something like this, where you have, it captures information around the account ID that was associated with an action, the username, in this case there was me, a principal ID, etc. So it captures more information. All of this is in a JSON document structure, so easily parsable, easily handleable. So going back to our event-driven security model, then we now have established two components, AWS CloudTrail as the event source and CloudWatch Events as the message bus or the channel. So for consumers, we have, again, a large selection of message consumers that CloudWatch Events can send these events to. For our purposes today, I'm going to focus on figuring out how this thing actually works, but AWS Lambda functions. So you can send these messages to many different services on AWS, but Lambda is what we're interested in today. And so this allows us to build out this event-driven asynchronous model for handling security events. So if Lambda is AWS's essentially functions as a service functions as a service. So they allow you to write code. You don't have to deal with the underlying operating system. You don't have to deal with the underlying infrastructure. You just provide code like a node function, or a JavaScript function, or a Python function, or something like that. They'll handle scaling the underlying infrastructure for you. They'll handle dealing with all of the scalability and security around that, and then you pay for it as you go. So the nice thing about AWS Lambda functions, or just functions as a service in general, is you don't pay for it while it's not running. So if your application, if nothing is happening, there is no payment or there's no cost associated with it. It's only when those functions are being executed. So in our model, for our event-driven security model, we now have AWS CloudTrail coupled with CloudWatch events, and then piping those off to AWS Lambda. If there are any questions, I can handle some of those now. If anybody has any pressing questions, or I can go on. Anybody? Yeah, go ahead.
I was curious, how do you secure those CloudTrail logs? What's a best practice? Or either keeping them in another account, or can you store them just in another bucket, so from another account, which is...
So I think best practice is, and what I've worked with customers on before, is to actually create a separate account. And that separate account is only used, for example, by the security team. So if you have CloudTrail events being generated and sent to an S3 bucket, you have that S3 bucket located in another AWS account with a very restricted set of permissions and privileges around those. Because ultimately, and I'll mention this a little bit later, one of the first things a bad actor is going to do in your system is try to disable CloudTrail to prevent you from looking and watching what's going on in the system. So if you can move those CloudTrail logs off of the system, they can't then delete that.
Thanks.
All right. Okay, so let's roll on. So for example, CloudTrail, so just to give you a little bit of history on CloudTrail on AWS. CloudTrail is a super important service from a security perspective because it provides us with the ability to log activity in our system and then to go back in and do forensic analysis. It allows us to build event-driven systems like the one I'm describing today. When AWS was first launched, there was no CloudTrail, and there was no ability to do this. And CloudTrail was just introduced in the last couple of years. And for backwards compatibility, AWS introduced it with the ability to turn it off. So by default, CloudTrail should really be on all the time. There's really no reason to never have CloudTrail on, even if you don't use it. It should always be there. But as I mentioned, one of the first things a bad actor is going to do if they gain access to your system is, well, I want to go turn CloudTrail off so that all of the actions that I'm going to take next, like creating new user accounts with elevated permissions, creating new S3 buckets, creating new Lambda functions, none of that activity is recorded. The resources will be there, but there will be no record of me doing that. So one of the first things we want to do is build a system that detects if somebody comes in and disables CloudTrail for us. And so I'm going to walk through a quick example here that demonstrates how you might do that. So say we wanted to build a system that really initially just notified somebody. It didn't take any automated action. It didn't mitigate the issue, but simply sent out an email or a notification or a Slack message. So say, for example, a user gains access to the system. They've gained access to credentials that allow them to disable CloudTrail. However they did that, through social engineering, however they've gained access to it. They're going to go through the CloudTrail API and they're going to try to trigger the stop logging API call on CloudTrail. CloudTrail is currently running, and so it is going to capture that event. And it's going to capture that event and send it to CloudWatch events. So let's look at how we might configure some of that. So CloudWatch events, without going into too much detail, allow you to set up event sources for a particular event. And in this case, we're going to configure CloudWatch events to use CloudTrail as an event source. We're going to set it up to watch for specific API calls, and in this case, the stop logging call. And you can see that at the bottom of the screen there. So now anytime a user interacts with the UI or uses an SDK or tries to call one of the HTTP methods associated with the service, this is going to be logged and triggered. Ultimately, though, we want that event to be sent to a Lambda function so that we can do something with it. That Lambda function, in our case, is simply going to take that JSON data structure that represents the event, like I showed earlier, and send it to a Slack channel. Very simple. This is a simple JavaScript function that you can run in Lambda very easily. And we're going to set up CloudWatch events to actually send the event to that Lambda function. In this case here, I'm simply going to take that JSON data structure and pass it directly to the Lambda function, and it can parse it and do whatever it wants to it. Ultimately then, though, I'm going to go into the console, I'm going to disable CloudTrail, and that's going to result in that Lambda function being executed and that message being sent to my Slack channel. In this case, I did a real simple message that said somebody disabled CloudTrail in US West 2, just as a demonstration of what you could do with it. You can certainly do much more complex, take much more complex actions than that using Lambda. You can do anything you want inside of Lambda. You can call existing applications, you can call other services, you can initiate actions, and I'll demonstrate another action you can take. So here's another example. Very quickly, I'll go through this one. Notifying someone again. So just another way of notification using Amazon's simple notification service, which allows you to send email notifications or SMS notifications or mobile notifications. So if you had an app you wanted to send this to, you could use SNS for that. The event-driven security model looks very similar. In this case, I've just replaced Lambda with SNS. Everything else looks exactly the same. User logs in, they try to make the change, that triggers a CloudWatch event. We're going to configure our event source exactly the same as we did before, and then we're going to notify someone. We're going to set up the target this time. Instead of it being a Lambda function, we're going to use an SNS topic. And that allows us to send that SNS to, you can send the SNS message to an SQS queue or wherever you'd like it to go. Again, we trigger it. Now, instead of a Slack message being sent, an email notification is sent to me, something like this. CloudTrail was disabled in this particular region by Jerry. So very easy to set this up. This is very simple, doesn't take a whole lot of effort or a whole lot of time to set this up and get something in place that allows you to detect when some of this activity is occurring. So real quickly, any questions or comments? Has anybody done anything like this before? Set it up, have anything in place? Nope.
No.
All right,
I have one.
Go ahead. Go ahead. It's good.
Me again. What if the intruder first goes to CloudWatch and disables the notification? Do you have a, let's say, a notification for that?
Yes, so you start to see that this is simply one step in many, that now you start thinking about, well, what if they disabled this, or what if they disabled that? And you can start setting up these same mechanisms for those. And we're starting to see frameworks built around this, because you can imagine, if you started doing that, you could end up with potentially tens or dozens or hundreds of these events that you want to handle. And so there are frameworks now that are being built around that allow you to handle that a little bit better. I'm trying to think, I'll think of the name of the company that has one that's very popular, but yes, you can do that. So you start building on there and you start seeing these layers of events.
Okay, thanks.
All right. So that is our event-driven security model on AWS. Again, very simple, very straightforward. If you have nothing in place, this is something very simple and easy to use and easy to implement. But I mentioned that I also want to show you the same thing or something similar for both GCP and Azure. And interestingly enough, and probably common, that the public cloud providers all provide very similar functionality and services. They're named differently, they're slightly different, but under the hood, in most cases, you can find service equivalents regardless of the provider that you're working on. If you're running on AWS, you can use the one that I showed. If you're running on GCP, they have these services available for you to use. Cloud Functions is effectively the equivalent of AWS's Lambda. Now, some of them are more mature, some of them are less mature, but it's fundamentally the same, building serverless applications in the cloud using Cloud Functions. Stackdriver logging, in this case, is our event source, so we can use it to actually capture and filter events and then use Cloud PubSub to ingest and deliver data. And so our event-driven security model on GCP looks exactly the same. There's no difference there to the architecture. We're using the same design pattern. And so we can start doing some very similar things with it. So if we want to send a message on GCP, it wouldn't be a CloudTrail message because there's no CloudTrail there, but if some other action occurred or there's some other event, we would follow a very similar pattern. So the user interacts with cloud APIs. We use Stackdriver logging to filter those API events and focus in on the events of interest to us. We then send that event to Cloud PubSub, which does very similar things or can do similar things to AWS CloudWatch events. So it can handle all of the subscriptions, it can handle retry logic, exponential backoff, shortcuts, circuit breaker activity, etc. And then can send that event information to the cloud function that you've designed. Ultimately, this will probably jump ahead. Oh, here's the cloud function. In this case, it's a JavaScript equivalent of the Python function I showed before. Again, just sending a simple message to Slack. This would actually look the same if I was using JavaScript or Node on Lambda or JavaScript on GCP, and it all looks exactly the same. So this is the really nice thing about this pattern is it translates very well across public cloud provider platforms and private cloud provider platforms. You can do essentially the same thing. Darn it. On Azure, again, just finding the right tools and the right services is all it takes to implement this same design pattern. You have Azure Functions, same as Google, same as or similar to AWS. You have the Azure Event Grid, which allows you to then manage the messages and manage the events and make sure that they're sent to the appropriate consumers. And then the Azure Resource Manager, which tracks interactions with Azure and changes to Azure resources. So very similar. The event-driven security model on Azure looks like this. Producer, channel, consumer, almost exactly the same, or really exactly the same as the other ones. All right, so again, quick questions if anybody has any. No? Anybody else? I'm going to roll right through. So one of the things that I wanted to show, and I won't go into great detail about this, is remediating public S3 objects. So one of the things we see in the news now, and I showed a couple of news stories earlier, was AWS customers leaving S3 buckets open, either intentionally or unintentionally. You know, having a public S3 bucket is okay if you have a public website and all the resources on there are publicly consumable. But if somebody takes an object and places it in that bucket and makes it public and it wasn't intended to be public, then you can run into problems. Or if someone takes an AWS S3 object that was intended to be private and makes it public, you know, customer resources, customer information, personal identifiable information, healthcare information, credit card information, then this can be a problem. Now, again, the first step to this is to make sure that we're using proactive methods to prevent this from happening in the first place, that users of AWS systems and resources should only have permissions to accomplish the jobs that they need to do. And so if they never have a need to change permissions on an S3 bucket, they shouldn't be given a role that allows them to do that. So there's step one, doing that. But again, a lot of these things happen because someone compromises a set of credentials or uses social engineering to gain access to credentials that allows them to take those actions. So very quickly, there's a simple mechanism that you can put in place. There are much more complex ones too, but this simple mechanism follows the design pattern that I've been talking about, using AWS CloudTrail, CloudWatch events, and Lambda to help mitigate some of these problems. Now again, it's not a real end-to-end solution. This is not a synchronous solution to this. All of these are happening asynchronously, but it does minimize the time between an event occurring and you being able to take an action and an intruder being able to get in and do something that they shouldn't be. So in this case, imagine someone logging into an AWS system and using the console to change the permissions on an S3 object. So they're going to interact. That's ultimately going to manifest itself as an API call to the S3 service. That API call is going to be captured by CloudTrail. And in this case, we want to look at specific API calls like put object or put object ACL, where someone might change the permissions on an object. We can use CloudWatch events to filter that specific object. We can then take that event and send it to Lambda. Lambda can turn around and make a call to the S3 service itself. It can look at a specific set of rules or permissions and determine that that object in that S3 bucket should not have been made public, and it can revert that change. So it can make it private again. Again, there is a time there. This is an asynchronous option, asynchronous activity, and so the time between detection and remediation, depending on what's going on in AWS, could be from milliseconds to maybe seconds, but you still have time to get in there. And you don't have to do just this. You can send out notifications. You can do other things as well. So just a simple example of how you can start going down the path of solving some of these problems that we've seen. So to close today, I really want to just summarize what I've talked about. At a very high level, I've described this event-driven security model and given you some examples of how you might see that on AWS, how you might see that on GCP and Azure using these services. It looks very similar on all of these platforms, and it's relatively easy to implement just the basic infrastructure. I've done this on all three of these platforms. Once you've done it on one, it's very easy. Other than just navigating the UIs for the different providers, the actual implementation is pretty straightforward and easy to do. At a very high level, this is how we've built this system out on AWS. You typically will have some interaction with an AWS API. Then that API interaction will be logged to CloudTrail. We'll set up CloudWatch events to filter those API activities on CloudTrail, and then we'll send those events based on that filtering to some other service. In our case, AWS Lambda, which can then take that event and send that event or take some action, can interact with other AWS services itself, or can send events or notifications to external services, or we can use other services at AWS like SNS. My real call to action today, and what I hope that you guys get out of this is number one, if you're working at a company or you yourself have an AWS account, make sure that number one, CloudTrail is enabled. If there's nothing that you get out of this talk today, it's that. It's make sure that CloudTrail is enabled. Two, make sure you've secured your S3 buckets, obviously. And then try to build some simple event-driven security framework to protect your assets on AWS. Because really what I don't want to see is another company in the news. It's too easy to find stories of companies who've left S3 buckets open or exposed their credentials. And I don't want to have to update these slides anymore. It's too easy to find them. So with that, I want to thank everybody today and open it up for any more questions if there are. And that was my feeble attempt to add some language appropriate content to my slides.
You got it right, actually.
All right, okay, good.
So, are there any other questions? Okay.
We're all good.
And thank you very much.
Thank you.
And with this being our final talk, I have just a 1-minute recap of what we have seen today. So we've watched Julia, and as she told us to watch over our engineers when they first touch something, like you watch your kids when they first touch a knife. Luke, he told us how important sessions and sessions are in scaling and how hard it is to manage database scaling. Ivan, he told us how he sees the DevOps engineer as a goalkeeper which supports the team. If you remember Alex, he told us that DCOS rocks. Nicolas, he said to not forget to budget for monitoring. If you remember Alex with the pink slides, he showed us how important communication is. And Tim, he showed us that we can deploy software even to turtles. So that concludes our conference for today. And this was DevTalks Cluj 2018. Thank you.